Hello everyone, welcome to another IGCSE Mathematics tutorial. Today we'll be discussing the second topic of the second chapter, Algebraic Fractions and Indices. First, we'll talk about manipulating fractions. When it comes to manipulating algebraic fractions, the rules are the same as regular fractions. To add and subtract fractions, first, you must make sure that you have a common denominator between both fractions, and then proceed normally. For example, let's simplify this. X divided by 3 plus x minus 4 divided by 2. We multiply the x divided by 3 by 2, the denominator of the second term, to get 2x over 6, and then we multiply x minus 4 divided by 2 by 3 to get 3x minus 12 over 6. We can see that they now both have a common denominator, 6. Our resulting fraction would be this, 2x plus 3x minus 12 over 6, which can then be further simplified to get 5x minus 12 over 6. Remember to keep in mind positives and negatives when simplifying to avoid mistakes. For example, if you have a fraction subtracted by another fraction, but the first term in the second fraction is a negative, make sure that the negative and the negative cancel out to become a positive. Let's continue. When multiplying and dividing fractions, simply multiply the numerators by each other and the denominators by each other. Once again, make sure to take signs into account. Our last case is an expression like this. 1 over x plus 2 plus x plus 1 over x minus 3. To simplify this, we need to make sure that they're both the same. So we multiply both the numerator and the denominator of each fraction by the denominator of the other as you normally would. So we do 1 multiplied by x minus 3 over x minus 2 multiplied by x minus 3, and so on. As so, and this can be simplified all the way down to x squared minus 2x minus 5 divided by x squared minus 5x plus 6. Let's talk about factorizing and simplifying rational expressions. Sometimes you'll be asked to factorize and simplify a rational expression like this one, x squared minus 2x, all divided by x squared minus 5x plus 6. Simply factorize both the top and the bottom separately, and then simplify the fraction if possible. Like this. First, x squared minus 2x can be simplified into x brackets x minus 2. X is the like term, we take it out. And then we simply add the terms required to make it into the original number. So x multiplied by x minus 2 would give us x squared minus 2x. Similarly, x squared minus 5x plus 6 can be split into x minus 2, all multiplied by x minus 3. You will notice something. We have x minus 2 in both of them. Our fraction right now would be x multiplied by x minus 2 divided by x minus 2 multiplied by x minus 3. As so, we can see that the x minus 2 is present in both the numerator and the denominator, which means that we can cancel it out, giving us x over x minus 3. Obviously, something divided by itself would give us 1, which means we can just cancel it out. Let's talk about algebraic indices. Sometimes questions will ask you to solve for x in a question like this. 32 to the power of x equals to 2. To solve this, write the expression in the exponential form with the base of 2. So, both sides, the base has to be the same. In this case, our number is a 2, so the other one has to be a base of 2. And we already know that 2 to the power of 5 is 32. So 2 to the power of 5x would give us 32 to the power of x. They're the same number. And on the other side, we have 2 to the power of 1, or just 2. We can see that now, since the base is the same, we can simply solve the powers on their own. They give us an expression, 5x equals to 1. We can solve this to get 1 over 5. Another example is this. 5 to the power of x plus 1 equals to 25x. Once again, write down the expression with a base of 5. Both sides has to have the same base, and then solve like so. 5 to the power of x plus 1 equals to 5 to the power of 2x. Since 5 squared is 25, 5 to the power of 2x is 25 to the power of x. Then we simply equate both sides. X plus 1 equals to 2x. We can solve for x, which gives us 1. This is a side note. Knowledge of logarithms is not required. Now we'll move on to the rules of indices. They're the exact same as the ones we discussed in chapter 1 for irregular numbers, no algebraic terms. We're multiplying two values with the same base but with a different index. We add the indices together, and in this case we can multiply any coefficients of the unknown term as well. So, for example, 3 multiplied by x to the power of negative 4 multiplied by 2 x to the power of 2 would give us 6x to the power of minus 2, since we have 3x to the power of minus 4, multiplied by 2x squared. The minus 4 plus the square would give us minus 2, and we do the 3 multiplied by the 2, the coefficients, to give us 6x to the power of negative 2. Similarly, when dividing, we subtract the indices from each other, and we divide the coefficients by each other. For example, 4 multiplied by x to the power of negative 4 divided by 2x squared will give us 2x to the power of negative 6. 4 divided by 2 is 2, minus 4 minus 2 is minus 6. When working with brackets, multiply the inner index by the outer index. So for example, 2 to the power of x, 2 multiplied by x to the power of 5, all of this cubed, would give us 8. The 8 is 2 cubed. X to the power of 5 cubed would be x to the power of 5 multiplied by 3, which is 15. Our answer, 8x to the power of 15. Thank you for watching. Make sure you like, subscribe, comment any questions you may have or feedback. Check out our channel for more videos on IGCSE Mathematics.